Hello everyone, this is Dr. Paul Rose again, and this is the next presentation in my series of short talks on the structure and content of a research project. We've now moved way down the diagram. We've gone past the introductory elements. We've looked at the research questions and how we would collect data to answer that research question. And we're now going to look at the results section, what you present from your data analysis and how you explain your findings to the reader. So the results section has several things that it does to tell the reader what your results are and what you have found out from your analysis. The results section describes the output of your data analysis. It describes your findings. It doesn't evaluate them, it doesn't interpret them. It simply describes the output of your descriptive and inferential testing. Descriptive statistics are graphs and charts, measures of spread such as means, medians and modes, and inferential testing are those analytical tests that give us a p-value, ANOVA, regression, chi-squared, so on and so forth. The results section explains what's being found out or what has not been found, i.e. by significant or non-significant p-values. It illustrates trends, patterns and relationships in the dataset, be they through correlation or regression, or maybe scatter plots, or various other illustrative statistics that you can use. And it should mix descriptive and inferential tests together. You should use a range of descriptive and inferential statistics for each aim or part of your research question that you are answering in that section of your results. The results section can be fairly weighty, 25 to 30% of your total word limits. It's going to depend very much on your research question, how much data you collected, and how many tests you have to run. Don't overanalyze your data. Don't do simply all the inferential tests available. That's called p-value fishing. It's unethical and it's bad scientific practice. Don't keep testing until you find the result that you want. Remember, when you look at your hypotheses, you should decide on what your data will look like then and consider what testing is most appropriate. Run the most appropriate tests, and if you don't get a significant value, it's not the end of the world. But don't keep running tests until you do find significance. That means your project isn't repeatable, it's not valid, and you're not following the scientific method. This amount of words, these 25 to 30%, includes your descriptive and inferential statistics. So all of the figures, tables, charts, and the text-based outputs that you're going to tell the reader about, that you're going to describe to the reader in your results. If you use particular types of approaches that need a reference, then by all means provide a citation. But similar to the methods, you don't need to discuss or evaluate in your results. Description of content is fine. Let's have a brief look at what the results section can look like. Try to lay out your results section by aim or part of the research question that you're answering. Just as I said for the data analysis section, if you lay out your data analysis by aim, then you lay out your results by aim, and then you evaluate those results by aim in the discussion, you have a nice narrative, a nice flow for the reader. Always mix together graphs and charts and measures of spread, your descriptive statistics, alongside of inferential outputs. Don't have pages of graphs and then pages of p-values. Include relevant graphs and charts and tables and relevant inferential outputs for each aim. Then move on to the next aim and do the same. Always provide tables with titles and figures with captions. Those titles and captions should explain the point of the table or figure to the reader. Underneath your table and figure, make sure you describe the important finding present in the table or on the chart. Don't assume the reader will know what you've got to look for. Tell them exactly why the table or figure is relevant. And check how you write up the output of your statistical testing. By that I mean you need to quote more than just the p-value. You should have what we call the test statistic, that is the number generated by that test, the F value for ANOVA, or the chi-squared value for chi-squared, for example. You might have to quote your N, the sample size that went into the testing. The degrees of freedom are also calculated for some tests that you run, and then you can include the p-value. The test statistic, the sample size, and the degrees of freedom tell the reader the validity and reliability of the statistical analysis. So make sure you quote them fully in the results section. To make that a bit clearer for you, here's an example of what a results section could look like laid out by the various aims of the research project. Let's imagine that this research project wanted to investigate the behaviour and welfare of ring-tailed lemurs. The research scientists involved had noted that the lemurs seemed to respond to different levels of visitors around their enclosure, and they wanted to know whether or not the degrees of visitation was affecting the welfare of the animals. So the first aim of this project was, do zoo visitors affect the activity patterns of ring-tailed lemurs? The first section of the results could present the time budget, simply the amount of time lemurs spend on behaviour, of various categories of visitor level, low, medium and high, and then a regression analysis could be performed to predict increases or decreases in behaviour with different types of visitor number. The second aim of the research was to see whether or not behaviour correlated with any physiological changes. So the research scientists collected physiological data, non-invasive metabolites of cortisol from urine and feces. So the results there would be the analysis of any correlation between physiological change and behavioural change. So they could be a scatter plot with a trend line plus the correlation output. And finally, if the scientists were looking at behaviour and physiology, they also wanted to look at space use. So they wondered whether or not the lemurs changed the amount of enclosure usage, the space that they were occupying, with different levels of visitation, high, medium and low. So here in the results section, to meet this aim, there could be a table of the amount of time the lemurs spent in each area of their enclosure, close to the public, far away from the public, for example. And these different amounts of time and enclosure zone with visitor category could be analysed using a Friedman's test. So this example shows you an inferential and a descriptive piece of analysis for each aim. And then the discussion section that follows on from the results could first discuss the activity, could then discuss the cortisol concentrations, and could finally discuss the enclosure usage. This allows the reader to see the narrative of the research and follow the story of why that research question was being answered. A few pointers on what not to include in a results section. As I mentioned previously, please do not evaluate or interpret any findings. That's what the discussion does. The results section simply states and describes the output of your testing. It describes your descriptive and inferential analysis. The results section should not contain screen grabs of the outputs of any analytical software. For example, if you've used Minitab or R or SPSS, don't simply screen grab the output of your ANOVA or regression and include that as a figure. As I mentioned previously, write out the test statistic, the sample size, the degrees of freedom and the p-value as appropriate for that test. It's never appropriate just to screen grab what Minitab or R has shown you. It should not include tables that repeat information presented in an earlier graph, and it should not include graphs that repeat information from an earlier table. One illustrative statistic per aim is enough. You don't have to tabulate and then graph the same data. And always remember to refer to cite your tables and figures in the text. For example, Table 1 shows or Figure 1 illustrates. Don't simply include the table or figure and expect the reader to know what it's telling them. So my checklist for what to include in the results section. Make sure you have a mixture of descriptive and inferential testing. Remember, your descriptive tests are your graphs and tables and your measures of spread. And your inferential statistics are those that include a p-value. Make sure you have a mixture of descriptive and inferential testing per aim that you are investigating. Check that your results section flows by aim or part of your research question. Mirror that from the data analysis section of your methods, and then further reflect it in your discussion. Make sure you fully explain the output of your testing. Is there the test statistic? Is there the sample size, the n? Are there the degrees of freedom, the df? And then finally the p-value. Remember that p-values alone don't tell the reader the validity of your analysis. Check that you've always labelled axes on graphs with units. The word frequency, for example, on a y-axis is meaningless to the reader. Always include units for numerics and make sure you have a full description for anything qualitative. Please give tables, titles, and figures captions and cite the placement of the figure or table in the text. And make sure you have described what each result shows. Make sure you always explain to the reader what they are looking for on a table or chart and tell them the non-significance or significance of the p-value. Remember, if you have a p-value that's generated from your statistical software where it simply says p equals 0.000, remember that's probably p equals 0.0000000 and somewhere there is a 1. So whenever you have a p-value that your stats program generates as p equals 0.00, quote that as p is less than 0.001, because somewhere there's going to be a 1 after a very long line of zeros. Hopefully that's provided you with the basics of how to include information in your results section. Please read widely around the subject, look at pieces of literature, of articles that have reviewed and evaluated the same topic as you, look at how they have analysed their data and follow a similar pattern. Again, it is not plagiarism to look at what other people have done for their data analysis and structure your results section accordingly, so long as you cite the precedent. Thank you very much.